Alright, so in this video we're going to talk about implicit differentiation. So let's start by looking at an example. Let's consider the slope of the curve y squared equals x at the point 4, -2. So let's draw this curve. So this curve is not a function, y is a function of x, because it doesn't pass the vertical line test. Okay, but we can identify the slope here. You can at least see it. Here's the slope at 4, -2. It looks pretty shallow. It's less than 1 and it's a negative value. Okay, so there's a couple ways to do this. So one, you can use what we call so there's a couple ways to find this slope. One, we can use what we've been doing before, and that's explicit differentiation. Okay, this curve is not a function, but we can find the function associated with this curve that contains the point 4, -2. So in particular, if we solve for y, we'll get y equals plus or minus x, and the minus part of this, plus or minus x, is the curve down here, which contains the point 4, -2. So once we have this function y equals the negative square root of x, or negative x to the 1/2, we can differentiate it. So dy dx equals -1/2 x to the -1/2, or -1/2 square root of x. And then we can put the point 4, -2 in. So in particular, when x is 4, this is going to be -1/2 root 4, or -1 2 times 2, which is 4, or -1/4. Okay, so that's called explicit differentiation. This y squared equals x curve is not a function, but we can find a function from it and then differentiate that function to find the slope. Okay, so now we're going to use implicit differentiation to solve this problem. And here we don't solve for y. What we do is we just differentiate both sides of this equation. We differentiate both sides of this equation. The right-hand side is straightforward. The derivative of x is 1. The left hand is a little more subtle. So y, we want to think of y as being a function of x. So when we take the derivative of y squared, this is a chain rule situation. We have y inside the square function. So when we differentiate this, we'll get 2y times the derivative of the inside, or dy dx. Okay? So it's really tempting to write just 2y, but y is an implicit function of x. We're not solving for it. We're just thinking of it as a function of x. And then when we differentiate y squared, it's like we're differentiating f of x squared. And so we'll get 2f of x times df dx. Same idea. All right, so now we have the derivative here, and we have this dy dx, and we can solve for it. We can isolate it by dividing both sides by 2y. And then we can evaluate the derivative at the point of interest. Here, the y value is the important value. Y is -2. And we get 1/2 times -2, which is, again, -1/4. So we're getting the same answer, but with implicit differentiation, we're not solving for y. We're just treating y like a function and doing derivatives right off the bat. All right, let's look at another example. Let's consider the curve x squared plus y squared minus 13 equals 0. And we're going to find the slope of the tangent line to the curve at the point 3, 2. All right, so we're going to use implicit differentiation. So right off the bat, we're going to differentiate both sides of this equation. On the left-hand side, we have 3 terms, so we'll be differentiating 3 terms. And on the right-hand side, we have 0, and the derivative of 0 is 0. So there's not much happening on the right-hand side. So just using properties of derivatives, we're going to take the derivative of each part of the left-hand side. And we'll get 2x from the x squared. We'll get 2y. Don't forget, this is an implicit function of x, so we have to include, by the chain rule, the derivative dy dx. And then we get 0 from the 13. All right, so then we have dy dx here. We want to find dy dx, so we're going to move the 2x to the other side. And we'll get negative 2x, and then we'll divide both sides by 2y, and we get negative 2x over 2y. Let's simplify this a little bit. So dy dx equals negative x over y. Those 2's cancel. And now we put in our point of interest, 3, 2, and we get negative 3 over 2 as our slope. All right, let's do one more example. So let's find the slope of the tangent line to the graph of x cubed plus xy plus 4 equals 0 at the point 2, negative 6. Okay, so again, we start by differentiating. So we'll differentiate the left-hand side. I'm going to distribute that derivative to all 3 terms on the left-hand side. And then we'll differentiate the right-hand side. It's 0, so again, not very interesting. We'll get 3x squared from the first term. And then we have this product. Now this is really subtle here. So this is a product. This is a product of x and y. So we need to use the product rule. We'll take the derivative of x, leaving the y alone, and then we'll take the derivative of y, leaving the x alone. So that's product rule applied to the xy product. And then we take the derivative of 4, we get 0, and the derivative of 0 is 0. All right, so let's work out these derivatives in the middle here. So derivative of x is 1, and the derivative of y is just dy dx. All right, so we have the dy dx here. We want to find dy dx. We want to isolate dy dx. So we're going to move the 3x squared and the y over to the right-hand side. So we'll get x dy dx equals negative 3x squared, negative y. And then we'll divide both sides by x, thus isolating the dy dx, and we'll have our derivative. And now we're looking at this point 2, negative 6, so we want to put 2, negative 6 into this derivative. 2, negative 6, so everywhere there's an x, we're going to put 2. And everywhere there's a y, we're going to put negative 6. And we'll get negative 12 plus 6, so negative 6 over 2, which is negative 3. So the slope of the tangent line to this curve at the point 2, negative 6 is negative 3. All right, I hope you found this video useful.